In this video, we're going to focus on solving acid-base titration problems. So let's start with this one. 24.7 milliliters of an HCl solution is completely neutralized by 35.8 milliliters of a 0.25 molar sodium hydroxide solution. What is the concentration of the original HCl solution? So we're going to find the answer using two methods, using an equation and by dimensional analysis. So let's use the equation first. The first thing you need to identify is the type of substance that we have. The acid is monoprotic, it only has one hydrogen. And the base only has one hydroxide ion per formula unit. If you see that, you could simply use this formula, M1V1, which is equal to M2V2. So we're going to say that M1V1 corresponds to the acid, and M2V2 corresponds to the base. And the reason why this works is because when you multiply the molarity, which is moles per liter, by the volume, you get the number of moles. The liters cancel. And in a neutralization reaction, the moles of the acid must equal the moles of the base. And so that's why that formula works for this type of problem. So in this example, we're looking for the concentration of the original HCl solution. So looking for the concentration of the acid, M1. V1 is 24.7 milliliters. M2 is 0.25 moles per liter. V2 is 35.8 milliliters. So M1 is going to be 0.25 times 35.8 divided by 24.7. So the concentration of HCl is 0.362 moles per liter, or simply capital M. Now let's talk about the other method that we can use to get the same answer. This is probably the most simplest method to use, just using this formula, if you have a monoprotic acid and base. Now to use the other method, you need to write a balanced chemical equation. So HCl reacts with sodium hydroxide, and this is a double replacement reaction. So H is going to pair up with OH, producing liquid water, and then Na is going to pair up with Cl, producing sodium chloride. So these two, they react in a 1-to-1 ratio. The molar ratio is what we need in the balanced chemical equation. Now our goal is to find the concentration of HCl. So we need to start with the stuff of the other substance. Once we could find the moles of sodium hydroxide, the base, that's going to equal the moles of the acid. And then using the volume of the acid, we could find the concentration. So I'm going to start with the molarity of sodium hydroxide. But instead of writing it as capital M, I'm going to represent it as moles per liter. So we have 0.25 moles of sodium hydroxide per liter of solution. Now let's multiply by the volume. To convert milliliters into liters, we need to divide by 1,000. So 35.8 milliliters is the same as 0.0358 liters. You can move the decimal point 3 units to left. Now notice that the unit liters of solution cancels. So now we have moles of sodium hydroxide, and we can convert it to moles of the acid using the molar ratio, which is 1-to-1. So for every mole of NaOH that reacts, 1 mole of HCl reacts with it. So now the unit moles of NaOH cancels. So now we have moles of HCl. To get the molarity, we need to divide the moles by the liters. And we have the volume of HCl, but we need to convert that to liters by dividing it by 1,000. So 24.7 milliliters is the same as 0.0247 liters. So to get the answer, it's 0.25 times 0.0358 divided by 0.0247. and you get the same answer, 0.362 moles per liter. So you could find the concentration of HCl using both techniques. Now what about this one? What volume of a 0.15 molar barium hydroxide solution is required to completely neutralize 45 milliliters of a 0.29 molar HNO3 solution? So like the other problem, we're going to get the answer for this problem using two techniques. So notice that nitric acid is monoprotic. It only has one hydrogen, but barium hydroxide has two hydroxides per formula unit. So therefore, we need to modify the equation. So I'm going to write the acid first, HNO3, and then the base, BaOH2. Now keep in mind, the moles of the acid must equal the moles of the base in a neutralization reaction. So M1V1, which is the moles of the acid, equals M2V2, the moles of the base. But in this example, barium hydroxide has two hydroxide ions per formula unit. So we need to incorporate that too. And we could put it on the same side that barium hydroxide exists. So M2V2 has to correspond to the base. We can only plug in the information of the base on this side. If we plug it in on the wrong side, we're not going to get the right answer. Nitric acid only has one hydrogen ion per formula unit. So we're going to put a 1 on the left side. Now let's go ahead and get the answer. So for the acid, M1 is the concentration. It's 0.29. V1 is the volume, 45 milliliters. By the way, if V1 is in milliliters, V2 has to be in the same unit, milliliters. If V1 is in liters, V2 has to be in liters. The unit have to match. Then we have a 2 in front. We have the molarity of the barium hydroxide solution. That's 0.15. All we need to find is V2. So now we just got to do some math. 0.29 times 45 is 13.05. 2 times 0.15 is 0.30. So to find V2, all we need to do is take 13.05 and divide it by 0.3. So V2 is 43.5 milliliters. So that's the answer to the problem, which I'm going to rewrite it here for reference. So let's see if we can get the same answer using stoichiometry. Feel free to attempt it if you want to. The first thing we need to do is write a balanced chemical equation. So barium hydroxide reacts with nitric acid. Now when H and OH gets together, it's going to produce water, as always. Now what about when barium pairs up with nitrate? What's the chemical formula between those two ions? Barium has a positive 2 charge. It's in group 2 of the periodic table, plus it has 2 hydroxide ions attached to it. And you know each hydroxide ion has a charge of -1, so barium has to be +2. Nitrate has a -1 charge, so the chemical formula for barium nitrate is Ba1NO3 2. Now we need to balance it. We have 2 nitrate ions on the right side, so we need a 2 in front of HNO3. And we have 2 hydrogens here, 2 hydrogens there, so there's a total of 4 hydrogens on the left. So we need to put a 2 in front of water, so we can have 4 hydrogen atoms on the right. So now the chemical equation is balanced. But what's important is the molar ratio between barium hydroxide and nitric acid. It's a 1:2 ratio. That's why we need to write the balanced chemical equation to get that molar ratio. So now, let's go ahead and calculate the volume of barium hydroxide. So let's start with the other substance, nitric acid. Let's get the moles of the acid first. So instead of writing 0.29 m, I'm going to write 0.29 moles of nitric acid per liter of solution. Next, let's multiply by the volume of nitric acid. So we have 45 milliliters, and if we divide that by 1,000, that's 0.045 liters. So now we have the moles of the acid. Now let's convert it to the moles of the base using a molar ratio. So for every 2 moles of nitric acid that participates in a reaction, 1 mole of barium hydroxide will react with it. So now we can get rid of the unit moles of nitric acid. Now the last thing we need is the volume. Let's get the volume in milliliters. Now we have the concentration of barium hydroxide. The molarity connects moles and liters together. So a 0.15 molar solution means that there's 0.15 moles of solute per 1 liter of solution. So since we have moles of barium hydroxide on the top, we need to put moles of barium hydroxide on the bottom. So 1 liter of barium hydroxide solution contains 0.15 moles of BaOH2. And I'm running out of space here. So we can cancel these 2 units. Now the last thing we need to do is convert liters into milliliters. 1 liter is equal to 1,000 milliliters. So now we can cross out the unit liters. So this should give us our answer. So it's 0.29 times 0.045 divided by 2, and then take that result divided by 0.15, and then multiply it by 1,000. And this will give you the same answer, 43.5 milliliters. Number 3. What mass of KHP, potassium hydrogen phthalate, will be completely neutralized by 32.57 milliliters of a 0.175 molar standard sodium hydroxide solution? So what do you think we need to do in this problem? We need to understand that KHP is a monoaprotic acid, and we can't use the formula M1V1 equals M2V2 because that formula doesn't correspond to mass. So the best way to get the answer is by stoichiometry. This might be bad news for those of you who really like those formulas. But let's start with a balanced chemical equation. So KHP reacts with sodium hydroxide. If you want to, you can use this, but I'm just going to use KHP. What you need to understand is that this hydrogen will combine with the hydroxide ion producing water. And once you take away the hydrogen, what's left over will have a negative charge, and that's going to pair up with the sodium. So this is going to be NaKP. If you want to, you can replace the P part with C8H4O4. But I'm going to write it as KHP because it's a lot simpler. So now, notice that in a balanced chemical reaction, KHP reacts with sodium hydroxide in a 1-to-1 molar ratio. And that's what we need. As you can see, there's only 1 acidic hydrogen in KHP. The other hydrogens are not acidic. Only the one that's listed to the left is the one that's acidic. So what we're going to do is start with the information of sodium hydroxide. We're going to get the moles of NaOH, then use that to get the moles of KHP, and then use the molar mass of KHP to get the grams. So if you understand how to do it, feel free to pause the video and try it. If not, sit back and watch. Let's start with 0.175 moles of NaOH per liter, as we've been doing before. And let's multiply that by the volume of the NaOH solution. But we need this in liters. So if we divide that by 1,000, that's going to be 0.03257 liters. Now let's convert from moles of NaOH to moles of KHP. So it's a 1-to-1 ratio. For every mole of sodium hydroxide that reacts, 1 mole of KHP will react as well. Now the last thing we need to do is we need to convert the moles of KHP into grams using the molar mass. So 1 mole of KHP has a mass of 204.22 grams. And so now all we got to do is just get the answer. So let's multiply 0.175 by 0.03257 and then multiply that result by 204.22. So the mass is equal to 1.164 grams of KHP. So this is the answer. Number 4. 42.6 milliliters of KOH was required to completely titrate 0.137 grams of KHP. What is the concentration of the KOH solution? Well, let's begin. So KHP is going to react with KOH. And every time H and OH gets together, they're going to produce water. After that, we're going to combine K with KP, so that's going to be K2P. And keep in mind, P is C8H4O4. So once again, we have a 1-to-1 molar ratio, which is what we're looking for in this example. So we want to find a concentration of KOH. Therefore, start with the other substance, KHP. So we have 0.137 grams of KHP. And let's convert it to moles using the molar mass. So 1 mole of KHP has a mass of 204.22 grams. Now let's change it to the moles of KOH using the molar ratio. So for every mole of KHP that is consumed in a reaction, 1 mole of KOH is also consumed. Now the last thing that we need to do to find the concentration is we need to divide the moles of KOH by the liters of the solution. And it's 42.6 milliliters, which is 0.0426 liters. So the answer is going to be 0.137 divided by 204.22, and then divide that by 0.0426. So it's 0.01575 moles per liter, or simply capital M. So that's the concentration of KOH in this problem. So this is the answer.